Welcome back to Chalk Labs. In this video today we are going to be looking at some of the work that I've done in configuring this power supply that I'm going to be using in my next project. So as many of you might have seen, and also as I shared in my last video was a review of a DC to DC converter that I'm actually going to be using in the charger, battery charger that I'm working on. It could be a battery charger, it could be an adjustable, customizable power supply, whatever you want to call it. So the project involves a lot of doing a lot of little things here and there, so I decided to kind of fragment it and show it stage by stage with all the work that I'm doing. So at this stage what I'm doing is, but before we get into it, I also wanted to mention that when you're doing something like this, you might want to make sure you protect yourself, wear gloves when necessary, and your eye protection when necessary. So I wouldn't really be too necessary for this. Back to what I was saying. So the first thing I needed to do was to configure this power supply. So this is something that most people on YouTube are doing, and they'll get a power supply like this, and this is basically designed to be a server power supply, or you can use a computer power supply, but I prefer to use this because they are a lot compact and cleaner, and the power density is amazing. I mean, this compact unit here pushes about 750 watts of power that you can use to do different things. So what I've done is to configure this power supply, and in order to do that I actually added an external output power enable switch. So, and you can find a lot of tutorials online on how to do this, but really there is no much need for it. So I will kind of zoom into these pads here to show how you need to configure this if you want to do this. I will maybe make a visual drawing of it to simplify how this is done. So also what I did was to add this connector out here to make it easy for you to plug in your load, and this is quite firm. I actually soldered onto it, and it's quite firm. It is not moving. It's very secure. So this power supply can actually is rated for 12 volts output at about 65 amps, so which is a lot of power for charging batteries or doing all kinds of things, hobby projects, DC. You can use this to drive your LEDs if you're into LEDs, maybe for one or two reasons, and you can use this to power your LEDs. So they come in handy to do many different things. And another wonderful thing is you can actually buy this supply working, good to go, reliable, for only, I think this came down to, I bought a pack of these, 4 of these. I believe then it was like $60, which means this guy only cost me about $15. And I know now you can even get them cheaper, especially if you buy them in lots. So I mean, you can't really beat this. So this is quite amazing. So, and nowadays, we've gotten to a point in our society and where things are cheap, and we quickly run to buying new things every time. Oh, I need this, let's go buy it. I need this, let's go buy it. And guys like this end up as e-waste and polluting the environment. So if we can find ways of do small projects like this that can where we can find in a way recycle this components or modules that would have ended up in e-waste, my guess is that would be a good thing. So in order to configure this power supply for use so that you can actually enable it, the way it is designed to have the computer system basically enable the output. So, but to kind of hack that, what I now did for some of the videos that I saw online and how guys that have done this before and share some tutorials, basically these two tabs here, this guy and this guy, or pads here, this guy and this guy, is the output enable. Some people use like a low value resistance or just jumper across it, and that way you can enable it. So I believe I used 39 ohms as to jumper across this, but I didn't put it here because I also wanted to add an output enable switch, this switch here. So what I did was I ran this to a switch, the output enable to a switch, and I also added some LEDs there to kind of show, you know, as a kind of output indicator when I have output. So the big pads that you're seeing here are the actually output pads that deliver us the 12 volts output. So this on the right side here is the 12 volts positive, and this is the 12 volts negative. So basically what I have done is to solder this connector here onto the pad, and as I was saying earlier, it's quite strong. It's really rigid. I mean, you're not gonna yank on it, there's no need to do that, but it's really rigid, strong. So, and in order to test it, and for kind of a small demonstration for this video, I made a little load, which is a 12 volt bulb, light bulb. I'm gonna plug in here and turn it on, and so you guys can see that it works. So that is it for the configuration. So this here is kind of a I did design some custom made again, this goes towards the bigger charger project that I'm working on. So I 3D printed some of the you can call this a switch holder, so that I can use it to secure. It makes it easier to toggle on and off the switch, and I can also, you know, mount some LEDs there, and you can see some of the bias and resistors that I used there. So some other examples that I made are these are the holders that I'm going to go over the power supply and secure it to the board that I'm going to use, and these are straps that will hold the wires in place, like so. So another thing I made for safety reasons, so whenever I'm working on something, so safety is always a big concern. So I made this. So basically the only function of this is to cover the power pads, because the last thing you want is for something to short these pads when you are charging batteries, or when you have this output enabled. Again, this output can deliver about 65 amps, and you don't want an arc. It could be really hazardous, so you don't want that. So I made this to go over the power output tabs like that, so that when I have this put together, I'll put screws here to kind of go over this, and they will secure it and kind of make it safe that way. I know a lot of people, if you're like me, you always have the curiosity to want to see what's inside this. So for that reason, I'm going to open it up so that you guys can take a peek at the inside to see what's inside. And for that, again, like I said, it's good to be safe. So I'm going to put on my gloves. And if you're doing this at home, I will also encourage you to do the same to stay safe. As you can see, this is metal housing and it has sharp edges, so you can you don't want something to nick or cut your fingers. So let's take this apart. It has a few screws to it, about maybe 4 or 5 screws. You take them all off. Hopefully we don't go too crazy here, and hopefully we don't lose any screws. And there should be one on this side, actually 2 on this side. So after you've done that, it comes off really easy. One more to go. You open it gently. There you go. So as you can see, this is really packed. So even if you're buying this for parts, there is a ton of parts in here that you can repurpose and use for other things. You have some cooling fans, you have you have a high frequency ferrite core transformer. Under here you have a lot of MOSFETs and diodes that are attached to this heatsink, and you have a huge capacitor here that you can also use for maybe other projects. So but then this is the breakdown. This is kind of what it looks on the inside. You plug in your power here. For a lot of people that really not to go into too much detail of how a switch mode power supply works, you have your input sine wave AC comes in here. That sine wave AC gets rectified to high voltage DC above 120 volts, and that 120 volts gets chopped down into what is called pulse width modulation. So that pulse width modulation control is now what is used to power this transformer. Then from this transformer it gets rectified again to the 12 volts that we have on the output here. This is a very multiple stage complicated process, so I'm just going over it and the kind of a high level explanation. But yeah, this is what it looks like on the inside, and there is a temperature sensor here that basically monitors the temperature, and it kind of senses how much load you're putting on this, and it tells the fan to turn on. Yeah, so this is a very wonderful, useful module to end up in the trash, to end up in the dumps, because we just want to go buy a new thing every time, and we don't want to, repurpose, cheap modules like this that's already floating around on the internet. So this is wonderful. I'm really, really excited. This is like Christmas for me, so I'm really, really excited to turn this guy on. So that's it on the inside. So you can put this back on. There are grooves to this side that you have to align. You align them in, then it should really flip back on, and then put the screws back in. Also, one thing I like to mention is if you just unplug this from power, you might want to be careful to make sure that, maybe give it some time to make sure that everything is fully discharged. And also, again, I recommend wearing gloves. What I'm wearing are not really electrical gloves, but it's better than not having anything on. So you get all the screws back in. It's a little bit harder to do this wearing gloves, but we have to be safe. And get the two on the side. Also, if you are watching this and some areas are like really not really very interesting for you, so you can skip through some of this and get to the areas you find interesting. But yeah, I know somebody out there could benefit from this level of detail, so that's why I'm doing it. So yeah, so this is the supply in a nutshell. So I like this one because it's really easy to configure. Again, like I said, if you don't want to go ahead with all this switching stuff and putting external enable switch, you could just grab maybe a low value resistor and go from. So if you're looking at this, what you're looking on this side is a negative terminal, output terminal. So if you count 1, 2, then the third pad that you see there is where one of the resistor pins will go to. Then you have, sorry, it goes 1, 2, 3, 4, 5, 6. So it will be 3 and 6. Your resistor will be going on pads 3 and 6. So I'm hoping that this video will be clear enough for you to see it. I will also have a visual drawing of this output pad on screen, so you guys can to make it really clear. Oh yeah, so after that, all you really gotta do is grab your power cable and you plug in. So, and I will demonstrate that next. So we have this is our output cable. Sorry, this is our power input cable, and to energize the module, you plug in your cable. Make sure your output is clear. There's nothing that's gonna arc or anything. So again, then I'll bring in my 3D printed. I designed this and 3D printed it all here at Chalk Labs. So you make sure you put this on to protect the output. And in the finished unit, there's going to be screws going through this, so it'll be really secure. It's not going to be moving. And this guy will be the enable switch. So now we plug in to 110 or 120. So I think I might have left it on, so let's turn it off for now. So this is kind of something I rigged up to load test the system to make sure that it's really working, and just for the purpose of the video. So you plug this in and you can see the power is in. So the good thing about the having the output enable switch is it allows you to actually have some second layer of control when you energize this module. So if I have put the resistor there, as soon as I plug in, I'll get an output. Maybe that's what I want, maybe that's not what I want. So I think it's preferable to have a switch connected to it, so that way you can control when you want the output to be enabled. So now if I toggle the switch, and you will see I added these LEDs here, like an output indicator, so you guys can see, or whoever is operating this can see that actually the output got enabled. Also, you will see this 12-volt bulb light up. There you have it. So we have output, and you can, if you also listen carefully, you can hear the fan begin to kick in to let you know that it's sensing some load on the output. I really don't remember what the power rating on this bulb, but I'm kind of glad everything is working. So to turn it off, turn off the switch, it goes off. Turn it back on, you hear the fan go off again. Then you can also see the LEDs. I added some I believe those are like 20k 20 kilo ohms biasing resistor to the LEDs, because I am biasing them with 12 volts, so I have to add high resistance to that. So if you're doing this at home, please know that you don't put these LEDs directly to the 12 volts. Put some high value. Again, I use 20k here to bias it. So we turn it off, and that's it. So you can see in here, this is a little bit I kind of hot glued everything. It's not quite very tidy, but so I use, I believe, 33 ohms for the output enable, and for the LEDs I put the LEDs in parallel. Then I put a 20 kilo ohm resistor to bias the LEDs. I believe at 12 volts that should be more than enough to supply enough current to drive the LEDs. So yeah, this is the configuration of the power supply. I decided to make it a little bit neat by adding all of this, and also a lot of this will be going to the next video, so the next project, which I'm going to be making the video very soon. And these are standoffs. The standoffs that's going to be for to mount the DC to DC converter. I'm trying the best I can to make it look nice and presentable, and something that somebody can actually hang in his or her garage with pride, and not look like have wires running all over the place like a crazy person. So if you want to see how this all turns out, please subscribe to this video, to my channel, and so that you will get notified when when I finish the battery charger project. So again, like I mentioned in the last video, I'm trying to challenge myself to see if I can get this all built up and under the cost of $50. So, and that will be including the power supply itself, the DC to DC converter, maybe not this guy, I don't know, we'll see. This guy, I'm adding this guy as kind of a convenience thing to be able to monitor your voltage as it comes in handy, instead of having like multiple 2 or 3 multimeters. One is measuring current, and one is and you have a current probe measuring current, and one multimeter measuring voltage. So this guy does it all. So but we'll see if I can be able to add it to the budget. Once again, thank you so much for watching, and thank you for being patient with this video. I decided to take my time to do this. If you found any of the areas boring and uninteresting, please fast forward, skip through it. But I decided to take my time to make this video stage by stage and show and talk through everything that I'm doing. I hope you found this informative. I hope you found it interesting. I hope you learned something from it, and see you on the next video.